So a piston and crank is something that you see absolutely everywhere. I mean, they're ubiquitous. They're the thing that's used in a car, clearly. And there are other uses for them, but that's where you find them mostly. Now, we're going to make it out of this stuff. I love a nice bit of hardwood. But when you go out and buy hardwood, obviously you have to go to a specialist hardwood supplier. These actually are a great alternative. This is a chopping block that I got from the local store. And that was £2.50 for that bit of beech, and there's a couple of bits of beech in there. And that was £2 for what I think is a redwood of some description, not quite sure what it is to be honest, but I bought them for the contrasting colour because models always look good in contrasting colours. Now you can go out and buy yourself hardwood from the hardwood supplier, no worries at all, but if you want a cheap source for the odd model that you're going to make every now and then, really just hunting around and keeping your eye open when you're in the store would be great. Now, when at full price, these are probably more expensive than buying the board, but these were in a sale, so they were half price, and this is cheaper than I could buy this bit at the hardwood supplier. So it's a great thing for small amounts of exotic timbers to make models with that can be sourced really cheaply. Now, to make a crank and piston, what we essentially need to do is cut this into a load of parts. And the biggest part that there is, obviously, is the crankshaft itself. Now, it's very little more than a couple of circles, so a hole saw will cut us out the main components that we need. So if those two circles get put on an axle, then there'll be a pivot point here, it'll go to a con rod which will lead to the piston. You turn that and the piston will move up and down. So it's a fine example of where rotary motion is got from linear motion. Now on other examples we've done rotary to linear. Here we're doing linear to rotary. So to make the piston, what I've done is cut 3 circles, and what I'll do is I'll stack those circles together and that'll be my piston. Now on a crank and piston you need 2 pivot points, one at the piston head and one at the crankshaft. So what I've done is I've cut another circle the same size as the piston, cut that in half, and that'll be mounted to the bottom, and you can see there's a hole drilled through, and that will be the piston pivot point. So it will go together like that with another piece of timber making the con rod. So what I'm going to do is fix that to there first, drilled and doweled, and then put those 3 together and then turn it so it's all the same size. So there is the piston finished along with its cotter pin, and that's a push fit into there. So what we'll do now is make a con rod, and that con rod will connect to the crankshaft and we'll have our 2 pivot points. Clearly that's got to run in something, so I've saved the offcuts and where I cut the discs, and that will actually become the piston cylinder, and the piston will ride up and down in that cylinder. So that's the cylinder put together. Now the piston fits just in there like that, and that's where it's going to go up and down, and we have a connection rod which goes to the bottom of the piston like that with a pin. We put that pin in there. Then we can see that the connection rod and piston are free to swivel, and that's one of the pivot points. Obviously the bottom here, which is called the big end, is the other pivot point, and that connects to the crankshaft. Now the crankshaft actually is little more than a couple of wheels. So I've got a couple of wheels here. Here is where the axle goes in the centre. Now quite often you find people putting an axle all the way through, and then they'll put the crank in and cut the axle out. Now that's really doable if your big end can unscrew, but mine's fixed, so I have to build it up in sections. And all you do really is put in one axle where the crank goes, the other axle, and then there. And that's what it looks like. So when that rotates, this moves up and down. Now the distance between the centre of this and the centre of that is the distance that is going to move, because that's connected there, that goes up and down, and it moves the piston by that distance. So once we put those together, now what you normally do is put a flywheel on. Now this is obviously a model, so I'm going to work this model by turning the flywheel. Usually, obviously, you have some petrol, it fires the piston, and the piston turns this. That's why it's linear to circular. So I'm going to connect all of that up together like that and put it in a couple of uprights so the whole thing can stand. Okay, so that's the crankshaft assembled, so we rotate that, then the whole thing goes in and out, which is awesome. Now all we have to do is connect the piston, which we do with this pin. There we go. and then put on the cylinder head. Now, I've done a cutaway, but on this side, because it flops that way, no surprise, it's got a pin in it there, so we fix the cylinder head and rotate it, and hey presto, the piston goes up and down, which you'd expect it to. But remember, this is linear to crank, so this would actually be a combustion chamber, and the motion would come from the piston, not the flywheel, and in the flywheel, so you can see the action of the crank. Anyway, that's it finished. I hope you enjoyed the video, and thank you very much for watching.